So in this problem, we're asked to determine the trip distribution for each approach shown in the map below. There's 4 intersections here, and we're told that we have a student career fair at the McKimmon Center, which is located here. And we're looking for the afternoon peak hour and where this traffic is leaving from the McKimmon Center. We're asked to complete this table at the bottom. So this is on NC State's campus, near the edge of campus. And so I think to me, it helps thinking about in big picture first, and then bring it into the smaller approaches that are going on. To me, my default, without knowing more details about this, just that it's a student career fair, is that there's likely to be more traffic at number 3 and 4. Number 3, because it's going towards main campus where there's a lot of housing, and then number 4, it's going towards Centennial campus and more housing. You can get other places at 1 and 2, but for me, my default would be, without looking at traffic volumes and other sets of information, which I would want to confirm and validate if I was using this for a real project. So my thought is maybe I'd have 30% going through 4, 30% through 3, 20% at 1, and 20% at 2. And so that's going to help me frame what I'm going to do for these individual approaches. So I'm going to write these numbers here again to kind of on each row. So I have a sense of what I'm trying to get those others to add up to. And so now I'll go to this first one, Gorman at Western. I think if you're going to come out this entrance from the McKimmon Center, there's not going to be a lot of right turns, but there'll be some, and there'll be some through movements and some left turns. So I would probably just estimate 8% left turns, 8% throughs, and 4% right turns. So we want, again, this to equal to the 20. And then overall, we want all of this table to equal to 100%. That's the goal here. The next one, we're looking at intersection number 2. I think there's going to be very little of this right turn. This just goes into some housing. So maybe I would put that right turn in number 2 at 1%. Similarly, I think to go left here, there's not going to be a lot because you would probably come out the other entrance of the McKimmon Center. So I'm going to do left of a pretty low number, but higher than the other one. So 4%, and I'll give the rest of the 15% to the through movement. And again, this is just a judgment. These aren't hard and fast numbers unless you have other volume data that you can help calibrate this information with. Number 3, I'm going to think the left turn is pretty small because if you're going to go left, you probably would come out of intersection 1. So I'm going to start with that one being a relatively low number compared to what I'm going to do for the other numbers. So maybe 5% for the left. I do think it's a heavy movement on the through and right. So I'm going to roughly split those. So maybe on the through, 13%, and on the right, 12%. And then finally, intersection number 4. I don't think there's going to be a lot of traffic turning left into Greek Court, Greek Village, or right, because I think you would go through another exit. So maybe I'll do 2% on the left and the right, and the vast majority here, 26%, being the through movement. So again, this should sum up to 100%. This is not super scientific. There's a lot of engineering judgment that goes into here, and I would like to look at more volume data and ideally origin destination data. There's lots of cell phone data aggregators I may pull in and look and see how they estimate the travel is going to happen from this location.